Hello everyone. This lecture is for the subject System Design and Analysis. It's a open elective subject in third year BE program of MBM Engineering College, Jodhpur. In this lecture, we'll try to understand the classification of systems, what are the different systems we use in daily life, and I'll see a few examples which will clear the differentiation between various systems. So we'll discuss in detail various systems right now in this lecture. We'll start with open loop and closed loop systems, which are very common, and many of us are known about these systems. So the open loop systems are the systems in which output has no effect on the control action as shown on the screen right now. So there is no control on the output. So these kind of systems are known as open loop systems. So this is a very simple definition and presentation of a open loop system. When you compare open loop system with a closed loop system, the only difference is the feedback systems. So if you have a feedback control in your system, then your open loop system converted into closed loop system. So all closed loop systems have feedback so that output can be controlled and we can change the input to control our output. So this is the basic difference between open loop and closed loop system, which is quite simple. Next comes the linear and non-linear systems. For linear systems, the output should be 0 for 0 input, and there should be not be any non-linear operator present in the system. So if you recognize a linear system, the two conditions which are important are that output should be 0 for any 0 input, and there should not be any non-linear operator present in the system. So if in your system mathematical equation, if you have a non-linear operator, then that system becomes a non-linear system. So examples of non-linear operator are shown on the screen right now. Non-linear operators are trigonometric operators like sine, cos, tan, cot, sec, cosec. Similarly, exponential, logarithm, logarithmic, and square, cube, all these are non-linear operators. So in this case, either input x or output y should not have these non-linear operators. This is the condition for linear systems. Now we'll try to understand this with an example. Two examples are shown on the screen right now. One is for the linear system. Equation is yt equals to sine tx t, and the second example is for the non-linear systems where you have two different equations. So you can easily understand that if you put x equals to 0 and your y is 0, that is a linear system. And you can easily see for the below example, yt equals to xt plus 3, the last line of this slide, first equation. So if you put x equals to 0, you won't get y equals to 0, you will get y equals to 3. So this kind of systems, these kinds of mathematical equations are known as non-linear systems. So this is how we differentiate between linear and non-linear systems. Next comes the time invariant and time varying systems. So this I will explain you through example, through a diagram shown on the screen. So there is an equation shown below this diagram, yt equals to x twice of t. So let us try to understand this. If you pass from the system first and then you go to the delay, then the equation changes like the above one. And if you pass by the delay first and then you go to the system, then equation changes accordingly. So this diagram shows the changes in equation if you run from the system first then delay, and alternatively if you go through delay first and then if you go to system, then the equation will be changed. So if both of these equations are same, then those systems are time invariant system, means there is no effect of the time on the system. But if you are getting different equations for these two pattern, then those systems are time varying system because they are changing with the time. So let us try to understand with this equation. So if you put this equation yt equals to x twice t for the above pattern, if this equation goes to system first and then delay occurs, then this equation converts as solution A, that is x in bracket twice capital T minus twice small t. Similarly, if the same equation we use for the second pattern, below pattern, then the equation, final equation we get as the solution B, that is small x in bracket twice capital T minus small t. Now you can easily see that the solution A and solution B are different. That means the same equation, if you pass through the above pattern, you get different answer, and if you pass the same equation with the below pattern, the answer will be different. So here for the same equation we are getting different answers. So it's a time varying system where you are getting different results for the different patterns. Now let us check another example by the same way. The same way we had a different example in previous slides. Now we'll see another equation, yt equals to sine of xt. Now if you carefully see the answer of this equation, if you pass by the above pattern, then you will get the solution A, and if you pass by the below pattern, the second pattern, you will get the answer as B. Now you can see that answers A and B are same. That means there is no effect of the time on the system. That means whether delay comes first or past the system, the overall result or the outcome does not change. So that's why these kind of systems are known as time invariant system, because there is no effect of the time on these systems. This is how we differentiate between time invariant and time varying systems. Then comes the quite simple understanding of continuous time and discrete systems. We all know that data are continuous or discrete. Now how we'll differentiate between continuous and discrete system, we'll see through some examples. So let us talk about some example of speed control of a DC motor. So here the output is the rotation in terms of radians per second, and it is a function of voltage and current provided as input to it on a continuous time basis. So such a system takes a continuous time input and provides a continuous time output. So those systems that use continuous time input and get continuous time output are known as continuous time systems. Similarly, if you take example of a generator excitation system where field current is adjusted based on the feedback from the output voltage generated to keep the output voltage constant, so you continuously getting feedback from the output voltage, and accordingly you are changing your output voltages. So you can differentiate between two systems by the diagrams also. Here for the above figure, for the continuous system the data are continuous, while for below system data are discrete. So if you are getting such kind of response in different systems, if you are getting response in discrete manner, those systems are discrete systems. Then next comes the single input single output systems, where you have a single input and you have a single output. Suppose is an example of a spring mass system. So if you put force on this, you will get displacement. So the only input is force and only output is displacement. So this kind of systems are known as seesaw systems, single input single output. Similarly, you have multiple output, multi input, multi output MIMO systems, where you have multiple inputs and multiple outputs. Like manufacturing systems is shown on the screen right now. There you have multiple inputs like sales, materials, energy, manpower, capital. Then you have multiple outputs like product, profit, reputation, waste, pollution, people, comfort. So there are number of inputs and number of outputs. These kind of systems are known as multiple input and multiple output systems. Then comes the lumped parameter and distributed parameter systems. The elements in a lumped systems are concentrated at singular points in space. Examples are electrical circuit with resistors, inductance, capacitors, current and voltage of time only. This you can understand by simple examples of loading pattern, which many of us are aware once we study mechanics of solids or mechanics in engineering courses. We come across point load and distributed load problems on a beam. So if that kind of a system is there where you have point loads, or you have some parameter concentrated at some different points. So that kind of system is known as lumped parameter. While if your parameter is spread over a length, then that is known as the distributed parameter system. Like we have come across the problems of distributed loading. So this is like that only. So if your parameters are distributed at certain points, this is a lump parameter system, and if you have distributed parameters, that is known as distributed system. So example here is electrical line where inductance, capacity and resistance are not constant but function of length. So here you can easily understand that inductance, capacity and resistance properties are not constant, but they depend on the length of the wire. So these systems are known as distributed systems, and they depend on both time and space. Then comes the deterministic and stochastic systems. Deterministic simulation models does not contain any probabilistic component. So here you can definitely you get a solution for a differential equation, and you don't use any probabilistic model in that. So this kind of system is deterministic system. While second is stochastic simulation models are those having some random input component. So you have some random effect on the parameter. Example is queuing model, where two consecutive customers and service times are usually random. So there is no certain deterministic pattern of judging something. So here this kind of systems are known as stochastic simulation models. They produce output that are also random. So randomness is there in stochastic simulation models. Then comes the static and dynamic systems. Static systems is a representation of a system at a particular point. That means you do not have any effect of time on your system. Estimating the probability of winning a score game, estimating the value of pi, all these are static models where you get certain value for a particular point of time. While the dynamic simulation model is a representation of a system as it evolves over time. So it is considered over a long period of time, like a models of bank and processors. So it takes time. So dynamic simulation model takes time, while static simulation model works for a particular point of time. Now we'll see this kind of various kind of systems with few examples, more practical examples that you have come across in your daily life, and you may get this kind of problems in your subject examination, vivas and interviews. So what kind of system is our temperature control system of our body? So how our body controls the temperature? So body temperature is regulated by a negative feedback. So as we need feedback in case of controlling body temperature, that's why it is a closed loop system. You can see by the diagram on the right side, if your body temperature exceeds 37 degree, nerve cells in screen and brain, they give signal to the brain. Then there is a temperature regulatory center in the brain, and we start sweating. So if your temperature changes, if the temperature around us are changing, then accordingly our body changes its system to adopt the changing temperature outside. So we'll try to understand this. So temperature regulation feedback system works by promoting either heat loss or heat gain. So once we get idea of temperature rising or lowering, then accordingly our system available in our body takes the decision of heat loss or heat gain. When the brain's temperature regulation center receives data from sensors indicating that body's temperature exceeds its normal range, it simulates a cluster of brain cells referred to as a heat loss system. So once our body gets heat, and this message goes to the brain, then brains controls the body and we start sweating. So this is how we go for heat loss. Similarly, if we face the colder situation where the temperature goes down, then activation of brain's heat gain center by exposure to cold reduces blood flow to the skin, and blood returning from limbs is diverted into a network of deep veins. Summary is that if our the temperature around us is getting higher, then we start sweating, and if it goes lower, then we start shivering, because that body controls as per the signal reached to the brain. So they we adjust according to the temperature around us. So this is a kind of a closed loop system. Similarly, there is a very common example of a washing machine, where typically a washing machine is a open loop system where you put all your clothes in a water tub, and then you set some readings, set some parameters for washing. You decide on the time period, you decide on the quantity of water, you decide on the time for which you want to run, you decide on the amount of clothes you want to wash. So all these settings you need to set before starting. So it's a simple instruction giving machine where you give instruction to the machine and it acts. So it's a typically a washing machine is a open loop system, but you can make it as a closed loop system. We'll see how we can do this. You can use sound level detection techniques, because that can be used to determine the point during water fill that the clothes have become totally immersed in the fluid. So you need not to set a particular time for water filling. You can use sound level detection technique that detects by the sound how much water is required more to fill the clothes. Similarly, you can determine the wash time and duration of agitation based on sense wash fluid turbidity, optical sensing, and fill level. So you can again use some sensors that senses the fluid turbidity. That means what kind of fluid we are getting on drain. That again decides for how much time you need to operate a machine. So those sensor automatically sense the property, sense the parameter, and that gives signal to the main processor of the machine, and then processor takes the decision to reduce the time period or to increase the time period, and to increase the water level or to reduce the water level. So this is how this kind of patent is already available. The reference is available in the last of this page. Below you can see a reference. So researchers are continuously trying to make it more advanced machines, more control loop systems where we can control the output effectively. That makes our systems easier, that makes our system less human interactive. So that makes us advanced machine manufacturer, advanced machine researchers. So all this is for the types of systems discussed in this lecture. We have touched upon a few examples that makes clear about the concepts of systems and how we can differentiate between various systems. Thank you very much.